Okay, if you have now the same function here, which is 1 over x, and I want you now to draw -2 over x. The first step now, I want to draw -2 over x. Before that, I must know 2 over x. 2 over x, here look at number 2. 2 is greater than 1, because when a is greater than 1, I have to make a stretch. So my graph now this is for 1 over x. I want now to draw 2 over x. So if I ask you about 2 over x, or sorry, -2 over x, the first step, remove the negative sign. It is 2 over x. Now 2 over x, 2 is greater than 1. And when a is greater than 1, I have to stretch. This is my first step. Then look at the -2. Now he told me that if the value of a, which is -2, is less than 0, you have to make a reflection. What's the meaning of a reflection? Like a mirror. Here I have the y-axis here. The mirror on it will be here. And here also, it will be here. This one for -2 over x. Is it clear now, Rose? Sorry, Sarah?
Teacher, can you repeat it? Just the last part of the reflection.
Okay. Now, I have my parent function is 1 over x. And I know how can I graph it? By plotting numbers, then know what are the x and y points or the xy coordinates, then put it on the xy axis. After that, I find the yellow lines, the yellow graph. Now, I need to draw -2 over x. To draw -2 over x, I need how it will be 2 over x. If I want to draw -6 over x, I need the positive one, which is 6 over x. After I know how 6 over x, I will reflect it. So here now I have to draw now 2 over x. 2 over x, where's 2 is greater than 1. Because a here is greater than 1. So I will make a stretch. Let's draw now the stretch line. This one and this one. Now after that, I go now to draw my function I want, which is -2 over x. Now -2, the value of it is less than 0. So I will make a reflection. How the reflection will be, look at the yellow one here and put a mirror and try to make a reflection on it on the quadrant number 2. Here, my first graph is in quadrant 1. The reflection will be in quadrant 2. And for the third here down, the 2 over x is in quadrant number 3. Sorry, this is not, sorry. In quadrant 3, so my reflection will be in quadrant 4. Is it clear now?
Yes.
Are you sure?
Yes, yes.
Okay. What also? Now go to the chapter test.
Yeah. Yeah.
Now, let's do number 6. Who want to solve it?
Teacher, press what?
Can I?
Can I? Okay, Hanin.
Press what?
Excuse me?
Press what? Like we have to
I'm sorry, page 554. I'm sorry. Okay, I will start with you one by one. Let's start with Hani. Suppose that x and y vary inversely, and x, so he told me that, here I have inverse variation. And x is 30 when y is 2. Now I want you to find y when x equal 5. This is now my question. For this one now,
We're supposed to find the constant of variation first.
so first we have to find the constant of variation. Thank you. For the inverse variation, how the function will be? It will be
y equals k over
x or k times x.
No, it's k over x.
K over x, thank you. Now after that, I have x and I have y. I need to find k. So y now? Yes, Hanin, continue please.
2 equals k over 30. And to solve for k, we're going to multiply by 30, so k equals 60.
So k now equals 60. Then after that.
So now we're going to say y equals 60 over 5.
Now y equals k over x, which is 60 over 5.
Which is y equals 12.
12. So here now, thank you, Hanin. Now here, I need to find y. I go to this function here. Y is k over x. Okay, I need to find y. X is known, it's 5. And k, it's also unknown. How can I find y if k is unknown? I go back to my given information that x is 30, y is 2, and I can find k now. After I find k, I go and evaluate it on the x in my function here, and then I can find y. Is it clear now?
Yes.
Yes.
Okay, now I want Habiba. Habiba, let's do direct or not. There's no other function that models each relationship. Okay, Habiba, I want you now to solve number 17. In lesson number 2. Number 17 here. Write an equation for the translation of y. Here, y is equal 4 over x. That has the given asymptotes. He told me that the given asymptotes x negative 3 and y is negative 4. Okay, I want you now to write an equation for the translation. Yes,
So
Habiba.
y equals
Okay.
four over x minus 3 -4.
See, Habib. Now, the reciprocal of the family of the reciprocal function told me that y equal a over x minus h minus k, where h is -3 and k is -4. Sorry, plus k. Then y is, where's a here?
It's 4.
It's 4, thank you. Over x minus, where's h?
It's -3.
It's -3. Where's plus k? Plus
-4.
-4, thank you. So the function of the equation will be y4 equal over x plus 3 minus 4. Not x minus 3 because he is here now, sorry, x minus h. So it is x minus -3. Is it clear now?
Yes.
Yeah.
Okay. I try to find some questions that have the same idea in the exam or in the quiz tomorrow. So there's no graph, okay? But there's a question I give you as a multiple choice, 4 graphs, and I ask you about them. Like I give you an equation and which function is related to this equation. Okay?
Yes. Okay, teacher. Thank you.
Okay. Now, 8.3. Before that, 8.1 and 8.2. This is now, do you have any question related to it for inverse variation and for the reciprocal function family?
No.
Okay. Now 8.3. Find the points for number, sorry, 8.3 here, I mean. Find any points of discontinuity for each rational function. Sketch the graph, there's no sketching. So I want you now to find here the point of discontinuity. And describe or tell me where is the vertical and horizontal asymptotes, and what also? How was the question yesterday? I asked you about point of discontinuity, vertical and horizontal asymptotes. Who can tell me? If it's removable or non-removable, and find the x and y intercept. This was the question yesterday. Is it right? In the trail quiz.
Yes.
Okay, like it.
And teacher, the remain.
Okay, tomorrow, inshallah, I will ask you to find as the same for yesterday, but with another equation. I ask you about point of discontinuity, removable or non-removable, vertical and horizontal asymptotes, and also for the x and y intercept. Let's now choose 21.
Teacher,
Yes.
what about the holes? They ask us in some questions to find any holes.
The holes mean like the zeros of the
Teacher,
function.
the whole is the removable point, yeah?
Yeah. It is the zeros of the function, of the denominator, sorry. Let's choose. No, I didn't want this one. Okay. Let's choose number 19. I want now. Rose. Yes, Rose. Number 19. Y equal
Y equal x minus 1 over
minus 1 over x minus
x plus 2.
sorry, plus 2, x minus 1 times x plus 2. Now, yes, Rose.
The
For this one,
removable discontinuity, it is
it is removable.
1.
Can you tell me why, Rose?
Because x minus 1, we can remove it with x minus 1 in the numerator.
Thank you. Since I can simplify, I can remove them because of that, I will name it with removable
Discontinuity at x equal 1.
discontinuity. At which
And
point?
we can read x equal 1.
X equal 1.
And in the graph, we can redefine x with 1 minus 1 over 1 minus 1, 1 plus 2.
No, no, this is for the removable. Now, sorry, what are the points of discontinuity? I want to go step by step.
Okay,
The
and non-removable discontinuity at x equal negative 2.
At x equal negative 2. Thank you. So, at x equal 1, I have a removable.
Can we say non-removable discontinuity?
Yes, yes, yes. At x equal 1 and x equal negative 2, these are my point of discontinuity. But it's removable discontinuity at x equal 1 and it's unremovable at x equal negative 2. Removable because I can remove it. Non-removable, I cannot remove it. I cannot remove x plus 2, but I can remove x minus 1. So since I can remove x minus 1, I name it with removable, and I cannot remove x plus 2, I will name it with non-removable. Okay, now the vertical asymptotes.
And the vertical asymptote, which is m, is less than n. So the vertical asymptote will be x equal negative 2. And it's not x equal 1 because it is a removable.
Can you tell us how can you find the vertical asymptotes?
Okay, like here the power of the numerator it is m, and the power of the denominator it is n. So if the power of the numerator, which is m, is less than the power of the denominator, which is n, so we can say x equal negative 2 is the vertical asymptote. But it is not 1 because it is a removable discontinuity.
Thank you. So she looked at the I mean that after I have simplified it, I have y equal 1 over x plus 2. So Rose, tell me now, the vertical asymptotes will be at where? At after I simplify it, I have x plus 2. So the vertical asymptotes add the zeros of the denominator when x equal negative 2. This is now the zero of the denominator.
And
wait, Rose, please. The others, is it clear?
Is x minus 1 not vertical asymptote?
No, because I remove it. I just use the x minus 1 to put it in removable discontinuity. But after I remove it, I have only this function. For this function only, I can find the vertical asymptotes.
Okay.
Okay. Now, so the vertical
asymptote
is at the zeros
teacher,
of the
is
denominator.
x equals negative 2 a point of discontinuity or a vertical asymptote?
It's a vertical asymptote.
Teacher, is it both?
It is both of them. It is the removable or the point of discontinuity at negative 1 and 1, and the vertical asymptotes at x equal negative 1, negative 2, sorry. It could be yes, point of discontinuity and vertical asymptotes. Yes, Rose. Now give me
And
now horizontal.
the horizontal asymptote, if m is less than n, so the y will be the horizontal asymptote will be y equals 0.
Thank you. Now Rose says I look at the power,
which is the x-axis.
and then the numerator. What is the power on the numerator? It is 1. Here it's x raised to the power 1. Look at the denominator now. Here I have x multiplied by x, which is x squared. So what is the power of the denominator now? It is 2.
2.
And since now the power of the numerator is less than the power of the denominator, I mean 1 is less than 2. So what I will say, what is my horizontal asymptote?
The horizontal asymptote will be y equals 0, which is the x-axis.
Thank you.
Teacher,
I'm sorry, yes, Sarah.
teacher, can you repeat how we find the horizontal asymptote?
Okay. Now, my function is y equal x minus 1 over x minus 1 over x plus 2. Now, to find the vertical, I need to simplify them. To find the vertical, I need to simplify them. So I have 1 over x plus 2. Then look at the zeros of the denominator, which is x equal negative 2. This will be my vertical asymptotes. Now, I want now to find the horizontal asymptotes. Now, for the horizontal asymptotes, he told me that look at the powers of the numerator and the denominator, the exponents of it. Here in the numerator, we have x minus 1. And in the denominator, let's multiply them. We have x times x, which is x squared, minus x plus 2x minus 2. Just multiply them. Okay, now? Is it clear now after I'm multiplying them?
Yes.
Okay.
Yes.
Now, what is the power of the denominator?
2.
It is 2. What is the power of the numerator here?
1.
1. Now, he told me that if m is greater than n, there's no horizontal asymptotes. If m is less than n,
So the
I
y
will say that the horizontal, it will be in y equals 0. This is a formula, or a rule, sorry, that if m is greater than n, there's no vertical asymptotes, horizontal asymptotes. But m is less than n, I will say that at y equals 0, at the y-axis.
teacher. And if m equal n, we will.
If m equal n now, I want to clear this. Now, if m equal n, like now, but if m equal n, what I have to do? Like another example, if you have 3x squared minus 1 over negative 4x squared plus 1. Look at the power of the numerator. What is the exponents or the power of the numerator? Can you tell me, Rose? Sorry, Sarah. What is the power of the numerator?
2.
It is 2. And the power of the denominator?
It's also 2.
It's also 2. Now, since the power of the numerator equals the power of the denominator, I have to choose, or to say, to choose the coefficients of the numerator, which is 3, over the coefficients of the denominator, which is -4. Then my new, or my horizontal asymptotes will be at x equal -3 over 4. At x or y? At y, sorry. At y equal -3 over 4. Is it clear?
Yeah, teacher, I still didn't say the y and x intercept.
Teacher, I have a question.
Yes,
When we want to find the vertical and horizontal asymptotes, do we look at the equation before or after we simplify it?
If you want to find,
Yeah, vertical and horizontal asymptotes, do we look at the equation before or after we simplify?
for the vertical asymptotes, after you simplify, please, girl, there's some use two devices, because I hear my sound 2 times. My voice, I hear it, sorry, 2 times. Okay, now, yes, Ziso-san, for the vertical asymptotes, you have to find it after you simplify. For the vertical, after simplifying. Like if you have x minus 2 over x minus 2 times x plus 3 times x plus 5. Okay? What I have to simplify them. After I simplify them, I get 1 over x plus 3 times x plus 5. After I simplify them, I can find now the vertical asymptotes. At x equal -3 and at x equal -5. But now for the horizontal, I have to go back to the first function, to the only before simplifying, and I look at the powers of them. How can I get without multiplying it? Just look up. What is the power? It is 1. And down, how many x I have?
It's cubic.
3 x's. I mean that the power here is a cubic or 3. So since now m is 1,
Y equals 0 is the horizontal asymptote.
yes, since m is less than n, so there's a horizontal asymptotes at y equals 0.
Teacher,
Yes.
this is in the quiz in rational expression. When we want to write it in simplified form, do we tip in the last step multiply them, or we can leave it like that?
If I ask you to multiply?
Yeah, no, like in the rational expression, when we want to write in the simplified form, should we multiply it or خلاص leave it like that?
See, if I ask you to simplify,
Yeah.
only simplify.
Yeah, like in rational expression, when we simplify it, should we multiply?
Wait. Let's take like 24, you mean? Look at the book at number 24. Did you mean like number 24?
Yeah, here in 20, yeah, 24.
Okay.
When we
In
factor them, should we multiply them?
Wait, please. In number 24 here, I have x squared minus 2x minus 24 over x squared plus 7x plus 12 multiplied by x squared minus 1 over x minus 6. I want now to simplify each rational expression. So here, the first step, let's factorize each numerators and each denominators. They are x 24, it is 6 and 4. Or no, sorry, here we have minus and here we have plus. Over 12, they are 3 and 4. So I will factorize them. Then after that, I will simplify. So after that, now the answer will be x minus 1 times x plus 1 over x plus 3. Okay, Rose?
it should be multiply the x minus 1 by x plus 1 or خلاص leave it like that?
No, keep it like this because I want you to simplify. If you give it back to x squared minus 1, you didn't simplify it.
Okay.
You must write the simplest form. Thank you.
Okay.
Okay. Now, do you have a question for 24?
No.
If I multiply or I'll divide, I have to do the same. But for the restrictions, you have to look at each denominator. I have to look at the denominators here and at the denominators here. So the restrictions here, it will be at point 6, at point negative 4, and at point negative 3. Yes, girls. Is it clear?
Yes.
Yes.
Yeah, teacher, I just don't understand how can a point be both a discontinuity and an asymptote? Like, it has to be one of them. How can it be both?
Yes, it can be. It's like,
Teacher, because the asymptote, when you grab it, you should not touch it, even in the discontinuity.
yes, so because of that, if you want to draw it, as an example, here I have my asymptotes. And also the point of discontinuity is also here. So it comes like this. Did you imagine how it will be, Susan?
Yeah, that is one weird looking function.
Yes, it comes like a hole, and here it will be open. It's me that's not included.
Okay,
Teacher, but the hole will be just for the removable bonds, right? Yeah.
For the removable points. Yes. Oh.
Yeah?
Yes. I think yes. إن شاء الله بكون طيب, now look at adding and subtracting. You have to find the LCD. The problem is the period is finished now. Okay, girls, let's finish because it's end at 9:30. Is it right?
Yeah.
Yeah.
How many periods there?
No.
Now you have we have also 5 and 6. Solving and adding and subtracting rational expression. Okay, at the next period we have a physics. I will take 5 minutes from the beginning of it to talk about how can we add and subtract the rational expression and how to solve them. Then we will start our physics period.
Okay.
Thank you, teacher.
Thank you for listening.
Can you send the model answers for these ones?
Yes,
And the
I will
chapter test?
tomorrow. I'm sorry, I forgot.
No, it's okay, teacher. Thank you, Red.
Mama.